What if I told you that everything you know about computing is about to become obsolete? Not in 100 years, not in 50, but potentially within the next decade. There's a technology emerging right now that doesn't just make computers faster, it makes them think in ways that are fundamentally impossible today. Welcome to the quantum revolution in artificial intelligence. Hey everyone, today we're diving into one of the most mind-bending topics in technology, quantum computing and AI. By the end of this video, you'll understand why the smartest people in tech are calling this the biggest leap in computing since the invention of the computer itself. And trust me, this isn't hype. The physics is real, the prototypes exist, and the implications are absolutely wild. Let's start with a reality check. Today's AI is impressive, right? ChatGPT writes essays, AI generates art, and self-driving cars are becoming real. But here's what most people don't realize. We're hitting a wall. Modern AI requires absolutely staggering amounts of computational power. Training a single large AI model can cost millions of dollars in electricity and take weeks on massive data centers. And there are problems, really important problems, that current AI simply cannot solve, no matter how much hardware you throw at them. Want to design a new drug? Current AI can recognize patterns in existing molecules, but simulating how a new molecule will actually behave requires modeling quantum interactions between atoms. Classical computers can only approximate this crudely. It's like trying to understand the ocean by looking at photographs. You miss the essential dynamics. Want to optimize a city's traffic system in real time with millions of variables? Want to discover new materials that could revolutionize energy storage? Want to model protein folding to cure diseases? These problems exist in a computational space so vast that checking every possibility would take longer than the age of the universe. We need a fundamentally different approach to computing, and that's exactly what quantum computing offers. Quantum explained. Okay, here's where things get weird. Your computer right now uses bits, tiny switches that are either on or off, 1 or 0. Every calculation happens by flipping these switches in sequence. It's linear, it's logical, and it's limited. Quantum computers use quantum bits, or qubits, and qubits operate by rules that seem to break reality as we know it. First, there's superposition. Imagine you're in a maze trying to find the exit. A classical computer walks down one path at a time. A quantum computer? It walks down all paths simultaneously. A qubit isn't just 0 or 1, it's both at the same time until you measure it. 10 qubits can represent over 1,000 possible states at once. 20 qubits? Over 1 million. 300 qubits could represent more states than there are atoms in the observable universe. And they're all being processed simultaneously. Then there's entanglement. Einstein called it spooky action at a distance. When qubits become entangled, they correlate with each other instantaneously, no matter how far apart they are. For computing, this means qubits don't just work in parallel. They collaborate in ways that create shortcuts impossible in classical systems. Think of it this way. If superposition lets you explore every maze path at once, entanglement lets those paths communicate with each other, eliminating dead ends before you even explore them. This isn't science fiction, this is actual physics, and it translates into computational power that's almost impossible to comprehend. So what happens when you combine this quantum power with artificial intelligence? You get capabilities that sound like magic. Let's talk drug discovery. Right now, developing a new drug takes 10 to 15 years, and costs billions. Much of that time is spent testing millions of molecular combinations to find one that works. Quantum AI could simulate molecular interactions at the quantum level because it is a quantum system. Instead of testing molecules one by one, it could evaluate millions simultaneously, predicting with precision which will work before you synthesize a single compound in a lab. Imagine a new pandemic emerges. A quantum AI system designs and virtually tests 10 million vaccine candidates overnight. 3 candidates move to clinical trials within weeks. That's not incremental improvement. That's a complete transformation of medicine. Material science is similar. Want better batteries? More efficient solar panels? Room temperature superconductors? These materials probably exist somewhere in the vast space of possible atomic arrangements. Quantum AI could explore that space efficiently, discovering revolutionary substances that classical approaches would never find. We're talking batteries with 10 times current energy density, or materials that could finally make fusion power practical. Then there's optimization. Modern life runs on optimization. Logistics, traffic management, financial markets, energy grids. These problems have so many variables that even the best classical AI uses clever approximations. Quantum AI could find near-optimal solutions to problems with millions of interconnected variables, managing complexity that's completely beyond classical reach. Picture this: an entire city's traffic system optimized in real time. Autonomous vehicles coordinated with perfect efficiency. Supply chains that produce zero waste. Investment portfolios that consider every possible market scenario simultaneously. But here's where it gets really interesting. Current AI is all based on neural networks, powerful but fundamentally classical. Quantum computing could enable entirely new types of AI algorithms that exploit quantum properties. Quantum neural networks might learn relationships that classical networks cannot even represent. We might create AI that thinks in ways that neither humans nor classical computers can comprehend. Section 4. The reality check. Now, before you think this is all happening tomorrow, let's talk about the challenges, because they're enormous. Quantum states are incredibly fragile. Superposition and entanglement last only microseconds before environmental noise destroys them. Current quantum computers operate at temperatures colder than outer space and still struggle with errors. It's like trying to perform surgery during an earthquake. Error correction is the big challenge. To run useful quantum AI algorithms might require millions of high-quality qubits. Today's best quantum computers have hundreds of noisy ones. Each logical qubit that can actually run calculations reliably might need thousands of physical qubits to correct errors. So what's the realistic timeline? We're in what's called the NISQ era, noisy intermediate scale quantum. We have quantum computers that can demonstrate advantages on carefully chosen problems, but they're not reliable enough for most practical applications yet. Most experts predict we might see early, fault-tolerant quantum computers with meaningful capabilities in the 2030s. Truly transformative quantum AI, the revolutionary scenarios we discussed, probably arrives in the 2040s or beyond, assuming continued steady progress. That might sound distant, but remember, the first transistor was invented in 1947. The iPhone launched just 60 years later. Technology acceleration is real. Section 5. The implications. If quantum AI delivers even half its potential, we're not talking about better technology. We're talking about a fundamental restructuring of human civilization. The optimistic vision is remarkable. Diseases that have resisted treatment for centuries could yield to quantum AI-designed therapies. Climate change could be addressed with quantum-discovered materials for carbon capture and revolutionary energy technology. Scientific progress could accelerate dramatically across all fields. But there are serious concerns too. Economic disruption could be massive. If quantum AI can perform complex analytical tasks beyond human capability, many high-skilled jobs could be automated. The enormous cost of quantum computers could concentrate benefits among wealthy nations and corporations, creating a new technological divide. Security is another issue. Quantum computers threaten current encryption systems. While solutions exist, the transition will be turbulent. And when quantum AI can optimize persuasion or predict human behavior at unprecedented levels, how do we protect human autonomy? Perhaps most profound, when quantum AI operates through principles we can't fully grasp, solving problems by exploring possibility spaces we can't conceive of, are we creating a form of intelligence that transcends human understanding? And if so, how do we ensure it remains aligned with human values? Here's the bottom line. Quantum computing isn't just a faster processor. It's a fundamentally different way of computing that could redefine what's possible. The quantum AI revolution isn't coming. In labs worldwide, it's already beginning. Today's quantum computers are primitive, like the Wright brothers' first airplane. But the trajectory is clear, and the physics is sound. When mature quantum AI arrives, it won't just make existing AI better. It will enable forms of intelligence and capability we can barely imagine. This future holds both enormous promise and real risks. Our challenge is developing it wisely, ensuring its benefits are broadly shared and its development remains aligned with human flourishing.